All right, so determining the concentration at equivalence point, the pH at equivalence point. So if we have 2.5 times 10 to the minus 3 moles of H4 plus 2.5 times 10 to the minus 3 moles of NaOH, giving us the formate ion, so 4 minus plus H2O. Okay, so if we've got 2.5 moles of this and 2.5 moles of this, we subtract 2.5 times 10 to the minus 3 moles, 2.5 times 10 to the minus 3 moles. And that's going to give us 0 of both of those things. Does everyone agree? Because they're at equivalence point, they cancel each other out. Okay? If we do that, we make 2.5 times 10 to the minus 3 moles of water and 2.5 times 10 to the minus 3 moles of the formate ion. So we make 2.5 times 10 to the minus 3 moles of that. Okay, because it's cancelled out. Now, in this case, this will have a pH equal to 7 because it's neutral. Okay? But the formate ion has a pH, doesn't it?
Yes.
Why?
Because it reverts back to
Formic acid. So it will make hydroxides. It has a basic pH. So then to do this part, what we do is we use the base dissociate, we use the Kb value, okay? So the first thing we do is we work out Kb, and Kb is equal to Kw over Ka, which is equal to 1 times 10 to the minus 14 over 1.77 times 10 to the minus 4. And that is equal to what? 5.65 or 4? Minus 11. Right, so that's what Kb is equal to. All right, all good with that. Right, let's put our K, let's take this, we'll move this value up here just so we've got it as a reference. So Kb equals 5.65 times 10 to the minus 11. Right, erase what's on the whiteboard. So, next step, write out our dissociation equation. So that's form minus plus H2O, giving us OH minus plus H4. Okay? So in this case, we have 2.5 times 10 to the minus 3 moles over 50 millilitres, which is 0.05 litres, plus H2O. So that's our initial plus 0 plus 0. Our change is minus x, so take x away from this, add x, add x. So at equivalence point, we then have 2.5 times 10 to the minus 3 over 0.05 minus x plus x plus x. Okay? Now Kb is very, very small, so we can use the approximation here. So then what we say is that Kb is equal to x multiplied by x over 2.5 times 10 to the minus 3 over x, over 0.5, 0.5. So then what we can say is that what's 2.5 times 10 to the minus 3 divided by 0.05? Hang on, can we get to I'm recording, I'll get back to questions in a sec. 0.05, right. So we're saying that we're saying that x squared is equal to 0.05 multiplied by 5.65 times 10 to the minus 11, and the square root of that will be equal to x. So 0.05 times 5.65 times 10 to the minus 11 will give us x. And that will give us our concentration of OH minus. And what's that equal to? You've got to go calculate it because I didn't bring mine. I'm just going to steal 18 so I can actually do the working out. And then I'm actually going to work out how to use this. 1.68 times 10 to the minus 6. And then our POH is equal to the minus log of 1.68 times 10 to the minus 6, which is what? 5.77. And then our pH is equal to what? 14 minus that, which is 8.33. 33. So it's basic at equivalence point. Mildly basic. 8.23. It is indeed. My mental arithmetic is off like a frog in a sock. All right.
So where did your x go in the form?
That one, it's tiny. We just approximate. We approximate it out. Okay. We do the approximation.
Wait, how do we rate?
How do we do? We do the approximation. Because we know that KB is very, very small, so X is going to be very, very small. Okay, stop there for a minute. Right.